So welcome to the class. So we are going to continue with our exposition on the topic of discussing machine learning applications, taking clue from the past successful applications, while trying to explore the present and future possibilities in our various fields of specialization. So last week we continue, we stopped where we presented some of our application areas in the renewable energy, biomedical prediction. So we are going to continue today with some of our application areas as it relates to some of the successful utilization in the area of cybersecurity solutions and applications. So common among the application in this area is the machine learning based model for cyber attribution. Cyber attribution, this was recently a thesis, one of my master's thesis actually defended this idea recently in our thesis work. We actually work on how can we attribute cyber attack to an individual or a group of people or to a country. So cyber attribution is one of the very challenging aspects of cybersecurity. So we want to know where is this attack coming from, because knowing that we create a lot of holes or a lot of kind of leap to know that, okay, how can we prevent it from happening? So there are different levels of cyber attribution. First of all, you need to know, is cyber attribution, is it from inside, that is within that particular organization, or from outside the organization? Then after that, we want to also see, is it within the country where the organization resides or outside the country? So the one we did of recent actually was based on trying to understand where is the attack coming from. Is it from within Saudi Arabia or from outside Saudi Arabia? So if we're able to identify where is it from, then we can then be able to move further to be able to identify possible suspects. But if it is from outside, also, at least it will prevent the investigator from wasting their time investigating inside me while it is outside. And if it is from inside, it will save them from thinking of outside and vice versa. So that is on the cyber attribution. And surprisingly, very, very few works have been done. In fact, no single machine learning application has actually explored this area. So, and then it was a very well and highly accepted idea when the student finally sent out some of one of our publications. So it is another very viral area, very versatile, very important area, so that we don't attribute the attack to wrong people, thereby hurting people that didn't offend us in the first instance. So cyber attribution will definitely be able to guide the authority to know where to put their searchlight on in determining who has actually attacked them. Another area here that have been is improved machine learning based email spam identification system. Here a lot of work has been done in trying to identify spam, because some of the cyber attacks actually comes in form of email spam. And once people click, then that is the beginning of the trouble. So if we can identify email that is coming in as spam or not spam, that could actually, this is a kind of a preventive measure to prevent attack that could come through spam or other stealing information of people. Now, so many other vices that people do through spam emails. So if we can quickly identify beforehand that, oh, this mail is not coming from the authentic people. Because no matter how you sensitize internet user in an organization, some people don't even have the time to even read the email to think that, oh, is it from authentic source or not? Everything is click, click, click. We have seen several people like this. Any email that comes to them, they must click whatever is there. So that's why we say, okay, why don't we spend more, invest more in trying to prevent the email from getting into the inbox of such people, so that we can totally, hopefully, prevent the huge effect of spammers. Now, so then we also have securing the deep learning-based object detection system. So this is another cybersecurity application of AI that is just coming up. So coincidentally, I happen to have one of my master's students also did a master thesis in this area. What is it all about? That is, we are trying to secure the object detection system, especially in self-driving cars, against adversarial example attacks. You see, self-driving cars is everywhere now. So some of us, I was made to know, actually, we are now having a couple of them now in the kingdom. So it's spreading everywhere. So where you have autonomous car that can drive itself. A student told me recently there was an accident involving one of such cars and camel, because the camel, maybe couldn't detect the camel, or the map was not to recognize camel. So many things could be responsible. But the idea is getting hold on the community, self-driving car. But one of the challenges of self-driving car is what we call adversary attacks. That is, a lot of systems are being built now that are based on AI. Now, people are saying we need to think ahead of not just building AI-based infrastructure. How can we protect this infrastructure? Because a lot of systems are getting to depend on AI. For example, a lot of biomedical systems that are monitoring the blood of people, monitoring the health of people. What if this is attack? And one of the attacks that people do is adversarial example attack. For example, you have a self-driving car that depends solely on taking a lot of images, pictures continuously, and those pictures are being analyzed to determine the next thing the car should do. Is it human being? Is it crossing? Should I wait? Is it just ordinary paper that is flying over taken by the wind? So that the car should know when to stop, because human being is crossing, or it is a camel. But if there's an attacker who is trying to attack this system, what they do is, when the system takes the picture, let's say it takes the picture, before the picture will get to the processing units, there is somebody will intercept that picture, and they put a lot of kind of override with some dirty crossing and kind of, we call this adversary attacks, trying to make it look like it's a fake image. So by the time the image gets to the processing unit, which is where actually the system will process it to identify the object. You see, because it's object detection. You have to detect the object in front of the car first before the car can take a decision. Should I go ahead, or do we need to stop the car? So imagine now it was human being, or it was a camel. However, the attack already took place, and now it is now portraying that object as a non-object. Just maybe ordinary paper, nothing is there. So the system will detect that, oh, there's no object in front of the car. You can continue to move. And then there will be a disaster. So this is a very common attack that is becoming a big concern to the self-driving car industry. Two years or thereabout, because self-driving car, one of the advantages that was promised is that it's not going to have accident, just like unlike human beings. But unfortunately, that promise was let loose when a self-driving car killed someone in the US. I think it was like a year and a half ago or 2 years ago. So this could be as a result of this kind of attack, or it could be other malfunction of the system. But however, securing self-driving car is a very, very important thing, as a lot of cyber attackers are targeting it, either for economic reason or for sabotage or whatever could be the reason. Now, so in this system, we have a security model for adaptive face authentication system using deep learning techniques. This is another area where you have talk of authentication systems. So how can we authenticate? We have so many methods of authentication, biometrics. Gone are the days of password, by the way. People are passing by passwords. It's getting obsolete. So we're talking of face authentication. We're talking of authentication that can use the temperature of the body of an individual, or the one that can actually determine is it you or not by just scanning the skin of your hand. Because there is recently got to know that people got to detect that there is a particular vein under the top of the finger or at the back of your hand that no two people have the same type of vein. This is another later result that people are trying to see that can we really secure a system by just you scanning, putting your hand there, scan, and then you can be given the appropriate authentication to get in, and so many other areas. That is under the AI-driven cybersecurity solutions and applications. So we also have the ML-driven frameworks for delay mitigation in tall buildings. So we discussed some of this last time. So like construction delay mitigation models. So how can we try to avoid construction delay, especially in tall buildings? Construction duration of tall building project estimation. Can we estimate ahead of time how much it's going to cost us? So that if the estimation is saying what is more than what we are actually planned for, we can possibly delay the building rather than go into abandoned projects. Because by the time you abandon a tall building, it will have been a big investment. And unfortunately, it's not easy to map up money to come and complete because it's usually a huge fund because of the size of the building. So it is good and better to do homework first by using this kind of technology to estimate what is going to be the possible estimation that we're going to need. Of course, cost estimation also is there. And also we have the ML budget for delay risk assessment. We want to have, there are different types of risks that can come in a project. So these systems are meant to try as much as possible to see what are the risks that are possible. Then we can then plan to see how can we mitigate some of this particular risk. So moving further, there are other areas, general application area like speech recognition. For those who might be interested in this, it's a very big area. We have the natural language processing that is working on trying to see, okay, how can we process your voice, which type of voice. For example, very nice application in this area, remember, is the trying to predict when somebody is angry. It was a system targeted at interviewers. You know, sometimes when people interview people on the TV or radio station, you want to know when the anger of the person being interviewed is at the threshold so that you can stop the interview. If some of us are aware of a very devastating event that happens not long, sometimes ago, where an interviewer was interviewing the ex-boxer. So, and then it got to a point that the boxer actually hit the person interviewing him because he felt he has crossed a particular level. So this kind of application trying to measure the anger level of people that you are talking to so that if it gets to a threshold, we can try to stop earlier before it gets out of hand. There's so many other application areas when it comes to speech recognition, processing, and also for other stuff we can use machine learning for. We also have computer vision. So mail sorting is a very popular area, and so many things have developed for computer vision. The autonomous car is, self-driving car is one of the areas where computer vision has been highly deployed. Very common, and so many other, there's so many deployments in this area, whereby cameras are fixed. So in computing, actually camera is one of the very difficult and computationally intensive processing to make in terms of input devices. So because when you take a picture, one picture is very heavy in terms of storage. So and then to process it, extracting the image, and then finally processing to identify the object. After you have identified the object, then goes the next level to know what do I do with this particular object that has been identified. So there's so many application areas. One of the very foremost at the beginning was the use of computer vision to sort. Mail sorting is very popular, but we have seen where people deploy it even in the production industry, like fish production process, where they are going to use it. Highly sensitive cameras are deployed to sort different type of fish as they are coming in the production process. So you can know that, okay, this is salmon, this is tuna, this is homo, different type of fish are sorted together. And then we have to determine the cost of misclassification appropriately. So if you are putting a wrong fish in a wrong basket, which one is more challenging? Which one should we avoid? Let's say, for instance, we have a fish in basket A and another fish in basket B. A single fish here is costing us, is at a cost of maybe like a 500 real. So why here, this one is costing just like 5 real. So when the system, let's say, sorting these two fishes, then these two categories, let's say sometimes the system gets confused, maybe because the camera is not clean or the fish coming in has some dust on it or some maybe mold is on the body. So which means the processing is going to be affected. Now I have a question for you. Now you have a system that is not able to identify a particular fish as either belonging to B or A group. So, and there are only two options for this kind of classification problem. Where will you throw it to? You see, imagine this is a fish. We don't know if it is 5 real or 500 real worth of fish. So if you throw it here, we put it here by mistake, that is going to be a disaster. Because anybody that purchased this particular fish will later find out that, oh, imagine purchasing 500 worth of fish and you find a very, very worthless fish inside. That's going to be a very big problem for the company. But rather, we can afford to, any time the system is confused, that you are not 100% sure that it is B, then please put it in A. So that someone, if you mistakenly find 500 worth of fish inside 5 real fish, the customer will be happy thinking that it was a gift and they will actually adversary the company. But if it's the other way around, that's going to be a disaster for the company. Because this person will be very, very mad, will be very angry that, no, how can you sell this kind of fish for me at such price? So this is what we call the actual cost of misclassification. Actual cost of misclassification. And it varies from process to process, from one application to the other. So this is in the production process. So if a mistake is going to come, it's better to make it in the less costly side. That is not going to have big effect on the system. But in other production process, it depends on what is involved and so many other things that we're going to see later on. So we also have several other applications in the biosurveillance area. Biosurveillance has to do with using machine learning to predict when there's going to be possible outbreak of disease. And I think this is one of the areas that the world has not really invested much in. A lot of loopholes are still there. That can we identify disease before they actually start, like just the previous pandemic. You see, COVID-19. Could we have even identified it earlier before it actually happened? So there are so many other, even common flu. Usually there are some times that when you go to the clinic, you see a lot of people in the clinic because many people suffer from flu because that is the season. But the season is not just a continuing. Maybe it could be for just 1 week or 2 weeks or 3 weeks. So can we really identify the week that is likely going to be the start or the onset of such outbreak, so that alert could be sent out to the people to be aware that, okay, if you must go to the park with your children, please make sure you go with them with mask, just to step down the rate of that particular infection of such flu. But like I said, biosurveillance is one of the areas that is, I don't know why it has not been catching the attention of people. Not very much work has been going on in this area. So recently we've been working on trying to do some of these things, like try to predict the flu onset in comparison with the Hajj gathering and Umrah gathering, especially in the Eastern province, trying to see the effect of also weather condition on the onset of flu at a particular point in time. So this falls under the biosurveillance. Other area of applications of machine learning, we have the robotic control system. So apart from which, of course, autonomous driving is one of them. There's so many robotic applications these days, so that's been deployed. So we also have the social network application, social networks. So this is where actually a lot of government now are taking advantage of this. So to know the feedback of citizens regarding their policies. To know the feedback of citizens regarding their policies. So in the past, we used to give, if you want to have an idea of how people are feeling about something, we have questionnaire. So you say questionnaire to people, you give it to them physically or through their emails, let them fill it for you. Often than not, you see people, usually if it is very sensitive questionnaire, maybe from government authorities, people tend to be afraid that, oh, if I fill this thing out correctly, maybe they will trace my IP address and know who is filling it. You see, So gone are the days. Now, these days, social network, social media has really made it easier for government to know what you are feeling, because nobody will give you a particular questionnaire to fill, but rather they will go and mine. So we call it sentiment analysis. Sentiment analysis on social media. They try to mine and see what you are talking to. Because when you are chatting with your friend, you are likely to be more truthful. And because you are not fearing anybody is watching you. And also the social media made it realize that you are being covered, your identity is covered, even though it's all another thing entirely. However, you feel that security, even though if the security is a false one, but you feel secure that, oh, I'm chatting with my friend. So, but when people have this kind of voluntary comments from you, mostly they think that it's more correct. So that's why a lot of people, government, companies are turning to social network to understand the feelings of people about their products. And that's why sentiment analysis is one of the application area of natural language processing that is really on the high rise. You want to know recommendation of people, the comment of people about a particular product. No one is going to ask you for questionnaire, but rather they go for your social network where you chat with your friend with ease, with relaxation, and they can get your feelings easily from these social networks. And there are several works in this area that is going on. A couple of them we have the opportunity to share as the time goes on, inshallah. So we have also debugging. So try to identify where there's problem in the code. Maybe you are a coder, you are coding, you are a programmer. So you want to identify where there's problem in my code, then the debugging system will be able to identify. You can even predict ahead of time where the error is going to be. And so many possibilities that machine learning can actually do in this respect. Then we have the empirical science. Empirical science, which actually covers several areas. See, you are in chemistry, you're in biology, anyone that goes to the laboratory, you generate data. So you can actually use machine learning to enhance your work. You see, if you are in chemistry, you are anywhere, even engineering. If you go to laboratory, you generate data, you can benefit yourself from those data. Enough of the classical way that we just use our data, do some little analysis, and that is done. Let us go back to history, bring out your data. Let's see how machine learning can actually assist you to put more value into those data, because machine learning is trying to benefit people from their data. Some of these data are wasting away, by the way. People thought they are just junk. Maybe 2-3 years ago, you did some things in your laboratory and you have the data, but you have already published it with your basic analysis that we usually do there in your area. That's fine. But machine learning is saying, no, don't throw them away. It is time for you to bring it back and come and benefit yourself from it. So using those data, you can actually try to understand the next experiment you are planning for. Maybe you don't really need to do that experiment. With the adequate knowledge, with the adequate information or data you have before, you can actually develop machine learning system that can predict what you try to do. You might only now need to do some samples to confirm what machine learning is predicting for you, to be sure that, is it really real? Because we have had a professor of chemistry that has that question that, hey, you guys, is it correct? So, Prof, go and check it yourself. Go to the laboratory again and do the experiment. You are going to get the same value that machine learning is predicting. So with your whole data, you can actually train your system to let it predict for you with just a few parameter changes. Maybe you don't really need to go ahead with the experiment we are planning. Even if you have to go ahead, you just need to do some samples to verify that what machine learning is giving me, is it really reliable? So many areas could fall under empirical sciences. So majorly in the sciences and also in engineering, anywhere you generate data, you can actually use machine learning to go in. So when I say your favorite areas, I know there are so many areas that could be your favorite. We come back to that. So we have asked us last week to identify some of the areas that you think is very important in your area, that in your area of specialization, that you can possibly deploy machine learning to see how it can work for you, and also not for you, to benefit humanity as part of this particular latest technology that is going on. Because like I said, at a point in time, using machine learning is moving from being an option now to becoming a necessity. So the publishing houses, if you're an academic, they are all looking for multidisciplinary research. Most of them now, just check your favorite journal, you see they might have new call for papers on a special issue relating to artificial intelligence in chemistry, artificial intelligence in biology. These are the latest area. Everybody is trying to key in to the technology that is actually taking the world by a kind of surprise, actually. So everywhere now, we are talking of data. Some people have opined that the next big stuff is going to be data, actually, not oil. Where people are going to make huge money from is data, and it's already happening. So that is why, like I said at the beginning of some of my lecture, we can't afford to be left behind. So we all have to move. So further application includes speech and handwritten recognition, autonomous robot control. We said that data mining about bioinformatics. So we have the motive alignments, playing games for those lovers of games, fault detection. If you're in the production industry, a lot of opportunity here. So whereby you have done the right thing, but the system is not just producing. Can we trace where is the fault coming from? What could be responsible? So machine learning could be. A lot of applications have been actually developed in this respect. Clinical diagnosis, I mentioned some of this earlier under biomedical research that we did. There's so many clinical diagnoses we can do. And I remember last week I did mention the idea of not just waiting to diagnose people. Why don't we preemptively predict if somebody is going to be sick? So that is what is actually part of one of our mega projects that has been ongoing for some time. So hope that they can see it can become available for everybody to use hopefully soon, inshallah. So we want to take diagnosis to the pre-symptomatic stage before people really get any symptom of any disease. Can we really know someone might be sick? So if we can predict there's going to be rain, and sometimes there's rain, so why do we wait for people to be sick? And by the time they make little complaint, then they say, oh, we are sorry, this is a late stage diabetes. Why do we wait for late stage? I want to believe personally, a lot can be done in this area to save humanity and at least detect chronic disease earlier before they cause havoc in the system. Spam email detection, we mentioned that, related or market basket analysis, which is under customer relationship management, CRM. It's another very big area that the business people are taking advantage of already. So we want to analyze the behavior of your customer. So customer who bought A is likely going to buy another product. So usually on regular basis, you see the shopping malls, the big shopping malls on regular basis, they do, what do? They do change their arrangements of places. See, today you see that some of the products are arranged this way. Some of them are arranged in different racks. After some time, maybe at the end of the month, you see they will exchange it. The product that used to be here might come here. Another one that used to be here might come here. They spend a lot of time and money on trying to do this rearrangement. Sometimes, do we think they do it just for cosmetics? No, it's not just to make it beautiful. No, they're actually using something that we call the market basket analysis. If analyze the purchasing pattern of people, and they have seen that there are some products that are being bought together. See, for example, someone who has just purchased a laptop is likely going to purchase a laptop bag or a mouse. So they would do the analysis already. They have seen how many people purchased laptop, and after that went straight to purchase the other one. You see, so what do they do in that respect? So they have to rearrange the mall in such a way that when you have your laptop here now, so ordinarily you think, since they know that anybody that purchased laptop is going to likely purchase bag, they should put them side by side. No, they won't do that. So rather, they will put laptop here and they will put the bag at the end of the mall here. So that once you purchase your laptop, you have to look for debug. In the course of looking for it, there's going to be a lot of advertisement for you. So as you go from here looking for debug, you see many things on the way which you are going to pick. That is advertisement, a kind of way of forcing you to see what they are selling. Since this is very common. And if there is any worthless product that they notice that no one has been, people have not been buying this product for a long time. So what do? They will put the products, they will say buy A and get B free. Nothing is really free. You see, this product used to sell for maybe $50, while this one goes for like maybe $5 ordinarily. So they will make the price of this one to become like a $51. Just they will sell it. Since people are not buying this B before, it used to be $5. People are not buying it. Just cancel it, put $1 on top of this. Buy A, get B free. So when you see A being sold for $51, wow, this second thing is going to be only $1, you go for it. Without knowing that people are not using it. I mean, people are not buying it. That's why they do that. So this is outcome of market basket analysis. So they will retrieve their stuff and then rearrange appropriately. Every time you see promotion there, except if you really need this stuff, then it pays you sometimes. That, oh, this is good. I've been looking for this product. But know that when you see this kind of thing, they have been able to analyze that, see that, look, people are not buying this thing, and maybe the expiry date is getting closer. Okay, we're going to match it with another product, and then people can hopefully take it based on the match. This is one of the area. Another area here under the customer relationship management, we want to see customer that is likely going to run away from our company. So people don't wait anymore because a lost customer is not just lost, but it's a potential enemy that will badmouth your company to other people. So that is why companies these days, they are more interested in retaining their customer. Apart from they are going to get more money from them, but they don't want them to become a potential enemy who will also scare other customers. So they have a system that will monitor the way you are, either maybe it could be the telecommunication industry. They will look at how much airtime you purchase. If they notice you don't purchase airtime, they start sending you almost free gift. You're going to give you, purchase just 10 real and you're going to get 30 extra, whatever. They give you very mouth-watering promotions, gifts to prevent you from going, because there is a system that already identifies you as a potential customer loss if they don't do anything about it. That is under the market basket analysis and customer relationship management using machine learning. And several work has been done in this area. We also have the finance credit scoring, detecting fraud. This is called under the anomaly detection. We want to detect, we know the normal pattern of purchase of people. So if someone is trying to use your credit card, a good system should be able to predict to the bank that this credit card purchase is not correct. It should be blocked. You see, unfortunately, not much effort has been done in this area. That's why you still see a lot of fraudulent transactions being made using other people's credit card. So once, if this could be really focused on, for sure, the pattern of purchase is going to be totally different from an ordinary person purchase. So this is under the fraud detection, and so many other also applications are going on. In manufacturing, optimization, troubleshooting, where the problem is coming from. These are all few, but several other are bound where we can actually think of application of machine learning. So I've talked about the medical diagnosis, I've talked about telecommunication, quality of service optimization, web mining, search engine, and so many other applications that are there. So the list continues. The list continues. Especially something unique I want us to take note is that applications are diverse, but methods are generic. This is a very important take-home point at this point in time, that the applications are very diverse. There are so many applications. See? So we can't cite them all. We can't list them all. Yeah. We cannot list them all. We cannot cite them all. Now, but the unique thing is that the applications, so many, We can't list them. And I know if I ask you to start listing your own application areas you can think of in your own specialization area, you're going to list so many of them. There's so many possibilities. In the last few hours, we've received a couple of suggestions from some of us here, based on my request last week, that we should identify some of the areas we are thinking. Some people already responded with some of the areas they think that they can actually use there. We're going to compile it and then see how also we can benefit each and every one of us from some of these ideas. I said, but methods are generic. The unique thing is that the same procedure of machine learning is common to all of them. You need your data. You need to get your data. Once you get your data, then you think, okay, what is the established point? Has anything been done in this particular regard in history? Of course, you look at the literature. What has been done? So, and the unique thing is that the fact that your data is coming from a totally different environment actually makes your work also totally different. Because let the data speak is already there. The same problem solved somewhere using another data, you might not be able to replicate that particular result using your own data. So which means your data becomes another interesting area for people to actually investigate, especially if the background are different. It's like, for example, when you are predicting clinical outcome of people, diagnosing people, we use data maybe from the US clinic, you might not be able to actually integrate it fully into another country, maybe like Middle East, because the lifestyle is totally different. You are going to have a lot of underlying genetic differences and so many other things that contribute to the fact that what we predict a particular disease in this part of the world might be totally different from another part of the world. That is why differences in data is a very important thing when we come to machine learning. So, and that is why it actually provides a lot of opportunity for people to really check out your own data. What can you do with your own data? How far can you go in actually doing what you are trying to get out? So the methods are generic, and I think we have discussed that particular generic method, time without number, where we did mention that we talk about no free lunch system, that is machine algorithms, the machine learning algorithms, they are tools, they are not dogma. So no classifier is inherently better, but rather we try to do what? You need to make assumptions and to generalize. So though the system is generic, there's no system you can say that this one is better than the other one. But rather, what do? We have what we call, I always tell us this, let the data speak. That is, your data will determine what you are actually going to use to do your prediction, depending on the problem you are trying to solve. So this is why we say that, this is when we say that the problem is diverse, but the application or whatever you want to use is actually generic. Now, and I think it's a very good place to maybe to call it a day at this point so that we can give room for you to ask your questions. If you have any question to ask, if you want to add something, you're always welcome. So thank you very much for this. And then we're going to continue from there next time, inshallah. Jazakumullah khairan. Assalamu alaikum.